Hey, happy Thursday, fifth graders. Welcome back to math class. Good seeing all of you, or not. Wish I could see all of you. Anyway, we're going to start with our joke of the day today. The joke is, why did the mathematician spill his food all over the oven? Because it said to put his food in at 180 degrees. Get it? Here's his food, 180 degrees, spilt all over the oven. All right, come back next week for more of that. Today, our lesson is multiplication of mixed numbers. So, again, as I said last lesson, it would be a great idea for you guys to take notes. And if you're getting behind, just pause the video anytime you want so that you can get caught up. So our math message for today says, talk with the partner about how the area model shown above represents the problem 28 times 6. So we're going to start with that one. You guys can draw an area number model. We've called this a couple different names this year. It could be an area number model, partition rectangle, and what's the other one? Oh, partial products. Really, this is just an example of partial products that they show here. So talk to a partner, dog, cat, brother, sister, anyone who is nearby. Talk to the wall if need be. Anyway, I'm going to take a look at my document camera with you to make this make a little bit more sense. So 28 times 6 is a hard one to do. So they take the number 28 times 6 and they split it into two easy parts. So we know that 28 times 6 is equal to 20 times 6 plus 8 times 6. So really, we just took 28, we broke it into two easy parts. One part being 20, the other part being 8. Okay, so really, we just took those things and we put it into this thing called the partition rectangle. Partial products is really what it is. So I took 20 and 8, put it up here, but I broke it up in two parts, 20 and 8, and I kept 6, just one simple part. The reason we break it up this way is because now we can do the rest mentally. We should all know that 6 times 8 is 48. And we should all know that 20 times 6 is something, but I don't know what 20 times 6 is. I know 2 times 6 is 12. Add a 0. Okay, it's 120. So then at the end, we actually have two answers. We have 120 and 48. And just like partial products, you take your answers at the end and you add them up. So you go like this, you get 8, you get 6. So our answer for that would be 168. So back to the math message. Then it says, work with your partner to draw an area number model that represents 4 2/3 times 7. So 4 2/3, obviously a little bit different in that we have a mixed number, and that's what our lesson's on today. How can we multiply mixed numbers by another number, whole number, or maybe even another mixed number? We're going to start with the mixed number times a whole number. All right, going back here. Here we go. So I did write that down as well. And you can see I already set up my partition rectangle. And the number that we're going to break into two parts that are going to be easier to work with is the 4 2/3. So I'm going to put that up top here, but above that box, I'm going to put 4. And above this box, I'm going to put 2/3. And then on the side here, I'm going to put 7. So the way that works is we're going to multiply 7 2/3, put our answer in the small box, and then multiply the 7 times the 4 and put our answer here at the end. We'll add them up. Start with the easier one. 4 times 7, that's 28. Okay, I don't know offhand, just mentally, what's 2/3 times 7. So what I want you guys to do as well is write out 2/3 times 7. Okay, I always think, hey, 7 is equal to 7 over anyone? Yep, you guys are right. Good answer, Joshitha. She said 1 if you didn't hear her. Oh yeah, I heard you, Tejas. You also said 1. Nice job. So 2 times 7 equals 14. 14 over 3. Okay, well, that's an improper ugly fraction, so we're going to make that a pretty mixed number. 3 fits into 14. 3 will fit in there 4 times. 3 times 4 is 12, so that leaves us with 2 extras, 2 over 3, so 4 2/3. I'll put that in there. And then at the end, you got to add the 2 boxes, just like we did with this one over here. So 28 plus 4 2/3 would be 32 2/3, which is our final answer. Let's circle that. Just go back to here, circle my final answer there. All right, so that was taking a mixed number times a whole number. And we're going to try one that's a little bit more challenging. We'll actually try 2 more. Any questions so far? Actually, you can't ask questions, so just hold on to your questions until our Zoom meetings. Remember, I've had some faithful participants joining us. Love seeing all those people, but would love to hear from more of you in some of our math open house Zoom meetings. So remember, those are on Tuesdays and Thursdays. Every day our office hours are posted in Google Classroom. So this is actually a heavy lesson, and starting now it's going to get really hard. So definitely write your questions down and join in. We'd love to see everyone participating in those things. Next problem, 1 3/4 times 2 1/3. All right, so you might want to write that number model down. But I noticed there isn't a whole number now. So when we make this partition rectangle, you're going to make your rectangle. Actually, I'll get a different color here. You're going to make your rectangle more of like a big square. And you're going to cut it into 2 parts this way, but you're also going to cut it into 2 parts this way, because each of these numbers we're going to break into 2 parts. So it doesn't really matter which one you put up top. I'm going to go 1 3/4 up top, and I'm going to go 2 1/3 on this side. Okay, so it's just like Battleship, just like coordinate grids, where wherever the numbers intersect, that box is where you'd put the answer. So right here would be 2 times 3/4. Right here would be 2 times 1, 1 times 1/3, and 3/4 times 1/3 would go here. So I'm going to start with the easier ones. Right here is 1 times 2, which equals 2. That's the easiest one. All right, now I'm going to go 2 times 3/4. Again, that's kind of hard for me to do mentally, so I'm going to be doing some side note writing here. I'm going to go 3/4 times 2. I always like putting 2 over. Jordan, what number is that? 1, did you say? Yep, you're right. Number 1. Good job, Jordan. 3 times 2 equals 6. 4 times 1 equals, thanks, Sahasra. Yep, that's 4. Okay, and then we could say 6/4 is equal to, well, 4 fits in there 1 time. There's 2 remaining over 4. So this 1 2/4 we're going to put in this box. All right. Who knows what we're going to do next? Actually, it doesn't matter. Yep, 6, you're right. We are going to do 1 times 1/3. Now, you guys remember, anything times 1 is itself. So I don't even have to do like a side problem. 1 times 1/3 will equal 1/3. Perfect. And then the last one, we have 3/4 times 1/3. I love seeing it side by side. That's just helpful for me. So I'm actually going to rewrite it over here. 3/4 times 1/3. All right, 3 times 1. Yeah, David, you're right. It's 3. Good job. 4 times 3. Yeah, Baron, nice job. That is 12. We got 3/12. So I got 3/12 right there. Just like that. All right, so earlier, move it down a second. When we had all our answers, we added them. Same thing. We got to add all 4 parts of these answers. There's only one problem. Yeah, you're right, Quat. You're right. We don't have a common denominator. You see, we got a denominator of 3, got a denominator of 4, and a denominator of 12. And you guys know, whenever you add fractions, you got to have common denominators, and this definitely does not. So this is kind of hard. What I would like you guys to do is below this problem, let's write out 2 plus, and I'm going to write 1 and 2/4 plus 1/3. Oh, you know what? I'll put 1/3 here. Plus 3/12. Now this is where you really got to know your multiplication, use your multiplication skills. Ask yourself, I don't know, can I turn 3 into 4? No. Can I turn 4 into 12? Yeah, I can. 4 times 3, and oh, yeah, 3 will go into 12. So really, if you look at this, I like to look at my largest denominator and say, is 4 and 3 like a multiple of 12, or could 4 and 3 also be a factor of 12? So this is where we're going to have to show a little bit of work. I'm going to multiply. We know our common denominator is going to be 12. How do I get 12 with 3? Times that by 4. Remember my math commandment, whatever you do with unto your denominator, you got to do with unto your numerator. Times that by 4. All right. And then I'm going to rewrite this fraction. So 1/3 would be equal to 4/12. Now I got 3/12 still over here. Now I got to change this one. I have a 4. How can I turn 4 so that it has a denominator of 12? Yep, that's right, Annika. Nice job. Times it by 3, she said. Yeah. Oh, and Levi, you're right. Yeah, we got to treat that thing the same. You got to treat them the same to keep them equivalent. Times it by 3. Well said. So now we have 2 times 3 is 6. 6/12. Okay. So if I'm looking at this, I got 1, 2, 3 numbers to add. I still got to put 2 over there. I don't have to do anything to 2 because it's already a whole number. It doesn't have a fraction. So now we have common denominators. Those are going to be easier to add. So I'm going to start by adding my 3 fractions. And I'll say 6 plus 4 plus 3. 6 plus 4 is 10. Plus 3 is 13. So be 13/12. And then I would say plus 2 is 2 and 13/12. But you guys know that that is an ugly, improper mixed number. So we got to make it pretty by saying 12 fits into 13 one time. So I'm going to add that 1 to 2 for a total of 3. And since it fit in one time, we'd take out 12 from that 13. It would leave us with 1/12. So our final answer is 3 and 1/12. Again, guys, this is some really complicated, heavy, new material. Just for one problem, look at all the work that we wrote down. Okay, so really, if you are at this point and you've done nothing but listen to this lesson, that's great. I want you to go back. I actually want you to show this work on some scrap piece of paper. It is necessary so that when you guys go to your math journal pages to work on this today, you have this as an example. Okay, write this stuff down. We're going to do one more together. Again, if you like to listen first, pause it, rewind it, go back. That's totally cool too. So we got 2 1/5. Draw a line a second. Keep our stuff straight. Maybe adjust my document camera a little bit. All right. So we got 2 1/5 times 2 2/3. So since each number is 2 parts, I'm going to make a square again. Same size. Break it the same way. Make it easier numbers to work with. I'll make 2 1/5, 2 here, 1/5 here. I'm going to make 2 2/3, 2 here, and 2/3 here. So I'm going to start with the easy one. Right here, it's 2 times 2, which is 4. Then I have 2 times 1/5. Since this is a units, or the units corn, as you guys 5th graders know it as, fractions, I don't need to show work, but if you want to, you could write that out. You just count by fifths. 2 times 1/5, 2/5. Okay, so our answer's 2/5 right here. Let's go to this one. I'm going to save the hardest for last. 2 times 2/3. I think I could figure that out, but I'm still going to show my work on the side here. I'll say 2 times 2/3. Remember, put 2 over what? You're right, Maya. Nice job. Put it over 1 so it stays equivalent to that number 2. 2 times 2 is 4. 1 times 3. Yeah, Gilbert, good job. That's 3. Nice work. All right, I got 4/3. 4/3 is equal to, well, it's improper. We got to make it, all 3 fits into 4 one time, and we have 1 left over 3. So our answer for this box is 1 1/3. All right, last box. We have 1/5 times 2/3. Definitely writing that out. 1/5 times 2/3. 1 times 2 equals 2. 5 times 3 equals 15. 2/15. Great. Last thing, we got Adam. Yeah, you're right. There is a problem. Good noticing, Izzy. I saw right away. She had a smile on her face. Yep, there's a problem. All right, we don't have common denominators. So what you guys need to do is look at that biggest denominator and say, is this 3 and 5 both either a multiple of 15 or a factor of 15? Is it? Yeah, they are. Yep. So we can turn 5 into 15. We can turn 3 into 15. Now, earlier above here, I did this side problem. I'm going to try something different, but I'll use a different color. Definitely when you're working in your journals, I want to see how you're finding your common denominators in your math journal. Even though I can't see your math journals, I want to know that you guys are showing how you're doing this. So again, we're turning 5 into common denominator 15. 5 times what's 15? 5 times 3. Great job, Gracie LeBeau. All right, and then got to treat our numerators the same. Times 3 there. And I'm going to rewrite this right away. It looks like we have 6/15. Okay, so this is our new number we're going to be working with in that box. So then here, we got to turn 3 into 15. 3 times what is 15? Jack Ryan, nice job. Yep, that's 15. Good job, man. And then we got to, sorry, I said 3 times 15. Jack, you had it right. I totally got that wrong. It's 3 times 5. Yeah, that's 15. Okay. And then we got to treat this thing the same times that by 15. So now 1 times 5 is 5. And 3 times 5 is 15. And then can't forget that whole number of 1. So really this thing here should be in this box. Okay. I don't know. It's a little less writing doing it this way, I thought, but maybe some of you prefer doing it on the side like we did earlier. Totally up to you, but you got to put it somewhere. Otherwise, it's way too much stuff to keep track in your head. Don't do it. Don't do it. Write out that work. There's not a whole lot of problems, and the reason is because there's a lot of work involved for each one. All right, now that we have our common denominators, we got to add them. And I am going to write this out. I'm going to do it side by side over here. I have 4 plus 6 fifteenths plus 1 and 5 fifteenths plus 2 fifteenths. And I can do this because I have 15, 15, 15. They're all common. All right, I'm going to do fractions first. Add those all up. 6 fifteenths. 6 plus 5 is 11. 11 fifteenths plus 2 is 13 fifteenths. And then 4 plus 1 is 5. The grand total answer for that last problem is 5 and 13 fifteenths. And if you have questions, write it down. Write it down. Maybe if you're actually taking notes, you could put like a question, confused look emoji, whatever you want. And that would be a good topic for us to talk about in our Zoom meeting. I'm losing track of our days. Is it Thursday today? I believe it's Thursday. And Thursdays, what do we got? 10 o'clock Zoom meetings, all right? Last thing, shout outs. Gotta remember who I'm doing it to. Oh yeah, there's my list. I want to shout out to Evie and Julian from Mrs. Howard's class. Evie, definitely miss the hard work that you give me each day, but I know you're still doing that at home. Miss working with you. Julian, miss your smile, miss talking to you about the Green Bay Packers. Hope you're still a fan. Hopefully we'll see him play this year. Baron and Jaden Vicari, definitely miss you guys. Miss your hard work. Miss joking around with you guys in class. And Cleve and Raksha, hope you guys are doing well, working hard. It's great hearing from you guys in email and seeing you guys' faces in our Zoom meetings. Keep up the great work. You guys are doing great. Hope you have a good rest of the day. Talk to you soon.